Okay, in this next section, we are talking about rational exponents. Now remember, rational is a fancy name for a what? Fraction. Good. So I have exponents. They're going to be in the form of a fraction. For example, I have the base x, and so in case you didn't realize that that's what this part right here is known as, that's your base. In this case, my base is x. Now, my exponent is m over n. And they each mean something differently, and you actually know what they both mean. It's just written in a different format. Okay, so let's make certain you understand the format. The numerator is known as the power. Second power, third power, fourth power, all that great stuff. The denominator is known as the root. Square root, cubed root, fourth root, all that. Are you with me? Okay, so before we get too much farther into this, I want to make certain that you know how to convert between a rational exponent and a radical. Remember what I mentioned in a previous lecture. This is considered a radical. And depending on the number written here, and that number is known as the index, it tells you which root you are dealing with. Is it a square root? Is it a cubed root? Is it a fourth root? What root is it? Are you with me? Okay, so, for example, write using rational exponents. So I have the cubed root of y to the second. With me? Okay, so to rewrite this using rational exponents, first we need to write the base. And my base is what? Good, y. And then the rational exponent means I'm writing a fraction, correct? Okay, so this y is going to have a fraction as an exponent. Now remember, the numerator of that fraction represents the power and the denominator represents the root. So in this particular case, what is the power on the y? Good, it's a 2, so that goes on the numerator. What is the root? It's a cubed root, so that's the 3 and it goes in the denominator. So another way to write the cubed root of y to the second is y to the 2/3 power. That's how it would be read. That's how you would say it. Y to the 2/3 power. Cool? Okay. By the way, let me give you a heads up. This problem could have been written as the cubed root of y, the whole thing to the power of 2. And it would still give you the 2/3 power on the y right here. Because the root is still 3 and the power is still a 2. Make sense? Okay, got another problem for us. With me? Okay, so let's start writing this. Remember, we want to write using a rational exponent. So what's my base? Some of you are like, it's the 4 and the x. Some of you are like, I have no idea. What's that 4 doing there? I get it. Remember, the operation between the 4 and this root is a multiplication problem, right? So I'm going to have 4 times something, aren't I? Now, what's my base? Yeah, the base is the x, because the x is the one that has the power and the root around it. The 4 is outside. It's not your base. Make sense? Okay, so the x has a power, doesn't it? Yeah, it's to the 5th power. But do you notice it's also under a root? And what's the root? 2, because it's a square root. Remember, when they don't write anything here, that is your square root. And so that goes in the denominator, doesn't it? So this problem rewritten using a rational exponent would be written as 4x to the 5 halves power. Cool? Are you with me? Okay, let me give you one more. Good? Okay, so what's the first thing we should identify? Good, the base. In this case, what's your base? Yes, it is the 3z because the 3z is under the root, so it's the whole thing, right? So what do you think when we write the 3z, what do you think we should put around it? Yes, parentheses, because we need to keep the 3z together because the 3z, the entire thing is under that root, so we need to keep the whole thing together. Now, rational exponents, I have a power, which is good, 2. And I also have a root, which is good, 4. So I have parentheses are read as the quantity. So I have the quantity of 3z to the 2/4 power. But do you notice 2/4 is still a fraction? And what do you always try to do with a fraction, whether they tell you to or not? Yeah, you try to reduce it. So clearly I can reduce this. This would be the quantity of 3z to the 1/2. Good? Awesome. Okay, hang in there. We're going to go. Okay, so let's go backwards. Write using radical notation. So let's take a look over here on number 1. I have 2m to the 1/3 power. Now they want us to use a radical. They don't want this rational exponent anymore. They want a radical. So we know somewhere in the answer is going to be a radical, correct? Okay. Now here's the question. We have to figure out what's under the radical. Is it the 2 as well as the m? And if you're like, I'm not sure, well, answer me this. Which one of these has the rational exponent? Good, it's the m. The m has the rational exponent. So what goes underneath? The m. So then where does the 2 go? Good, the 2 goes on the outside because it doesn't have the rational exponent, does it? Okay, so now we need to figure out what the power of the m is as well as the root. So on the m, I see the 1/3. So 1 represents the what? Good, that's the power. And the 3, that's the root. So m is to the first power, and it's under a cubed root. So m to the first would just be what? Yeah, m. So your final answer would actually be rewritten as 2 times the cubed root of m. Does that make sense? Okay, good. Let's look at this one over here. They want us to write with a radical notation, so we know in the answer somewhere there's going to be a radical. And now the question is this. What's under the radical? Good, it's the 2x under the radical. Why? Because it's in parentheses. And outside the parentheses is the rational exponent. So inside the parentheses is your base. My base is a 2x. Whereas over here, just the m had the rational exponent, so just the m was your base. Good? Okay, now, what does the 3 represent? The power. What does the 5 represent? The root. Okay, now there's 2 ways you can actually write this answer. So, I have the 5th root, don't I? And the whole thing could be to the power of 3. Or, we still have the radical with the 2x. We still have the 5th root. And the power of 3 is to the entire 2x. Both of these are correct. Both of these mean the exact same thing. I've got a 5th root, the whole thing to the 3rd power, or the 2x to the third power, then take the fifth root of the whole thing. Both of these answers are correct. I just need you to be aware of that. Good? Okay, now, we're going to put these rational exponents into practice, so stay tuned. Okay, look at these directions. They say simplify if possible and write with positive exponents. So, if we have exponents left in the answer, they must be positive. Got it? Okay, but the first part says to simplify. So let's take a look at number 1. Number 1 is telling us to simplify, if we can, 27 to the 2/3 power. Now, let's backtrack and remember what this means. What does the 2 represent? It means the power. What does the 3 represent? It means the root. So, if I think about it, I can actually rewrite this problem. What's my base? 27. And the 27 is sitting under a cubed root, isn't it? Because that's what this 3 means. And it's also, though, to the second power, isn't it? So here's the deal. Remember, there's 2 ways of writing that second power. I can write the whole thing to the second power, and that is actually equal to me taking the cubed root of 27 to the power of 2. Remember, both of those are exactly the same. So here's the deal. It's your choice on how you're going to figure this out. I don't have a calculator in my hands. So if I want to figure out 27 to the power of 2, I'm going to need my calculator. And that's going to be a pretty big number. Not too large, but large enough that I would need to use my calculator to come up with the cubed root of that number. So go ahead, punch it in. 27 squared, figure it out. And now on your calculator, take the cubed root of that answer. You got it? Okay, hold that thought. Because me, without my calculator in my hands, this first way that I wrote it would actually be a lot simpler for me. Why? Because I know the cubed root of 27. What's the cubed root of 27? Yeah, the cubed root of 27 is 3. So in the parentheses I would have 3, and I would still have the power of 2, wouldn't I? Which would give me 9. When you punched it into the calculator and you squared the 27 and then you took the cubed root of that, did you also get 9? Yeah, I bet 27 squared was 729, wasn't it? And then you took the cubed root of 729 and you got 9, didn't you? Exact same answer. Are you with me? Either way works. Me personally, I like to take the root first because it's easier normally. And then I'll take the power second. Same answer, doesn't matter which one of these ways you do it, same answer. Got it? Okay, let's look at number 2. Now, I have a question for you. Is my base a negative 64 or is my base just a 64? And if you're like, I'm not sure, we have this original problem versus this problem. Over on this other part that I just wrote, what's your base? Oh, you're like negative 64, of course. Great. How did you know it was a negative 64 here? Because of the parentheses, right? Do you see parentheses holding this negative and this 64 together? Nope. So what's my base here? Correct. My base here is just a 64. So under the root would be a 64. So now the question is, where does the negative go? Yeah, the negative's on the outside. Got it? The negative is on the outside because there's no parentheses holding the negative with the 64. Cool? Okay, so here's my rational exponent. What does the 1 represent? Well, that's your power. What is the 2? That's your root, so I know I got a square root, right? And to the power of 1, well, anything to the power of 1 is just itself, right? So I basically have, the problem I'm basically working on is a negative times the square root of 64, right? Well, what is the square root of 64? Yes, it's 8. And that negative is still on the outside, isn't it? Anything more? There's my final answer, -8. Good? Okay, let's look at number 3. So, in this case, what's your base? Yeah, your base is a 16x to the 8th power. Why? Because it's in parentheses, which means under the radical will be a 16x to the power of 8. And what's the root? Yes, the root is a 2. And my power is still a 1. Well, that's not going to change anything, is it? Okay, so remember in a previous lecture, since this is multiplication between the 16 and the x to the 8th, do I have to keep them together or can I look at them separate? Yeah, you can look at them separate, right? And as a matter of fact, hold that thought. As a matter of fact, couldn't you have done that up here? Yeah, I could have done it right here. So you know what? Hang in there. Let me erase this and let me show you that you could have actually done it right at the start here. You could have actually split this up as 16 to the 1/2 power times x to the 8th, which is also to the 1/2 power. Are you with me? Okay. What does this mean then? Yep, that is a square root, isn't it, of 16, which we know is what? Yeah, that's a 4. So this being a 4, I already know part of my answer here is 4. Now, x to the power of 8 to the 1/2. Do you remember what you do with numbers between parentheses? Yeah, don't you multiply them? If I gave you a problem that looked like this, wouldn't you distribute the 2, right? Same thing. I then have x to the 8th times 1/2, don't I? Well, what is 8 times 1/2? Yeah, that's 8 over 2. And that's a fraction, isn't it? 8 over 2, what does it reduce to? 4. So this becomes x to the power of 4, doesn't it? That completes your answer. 4x to the power of 4. Cool? Yeah, this is another way of looking at doing this particular portion of it without putting it under a radical. But it's a common sense thing because you're like, well, through parentheses we always distribute. Well, through parentheses I'm going to distribute the 8 and the 1/2. Good? Okay, let's look at this last problem. What's my base? Yeah, -25 because it's in parentheses, correct? So under the radical will be a -25. What's your, yeah, the root is 2. It's a square root, isn't it? And the power of 3. And as we discussed up here, it's easier to take the root first and the power second. So now you got to take the square root of -25. Yeah. Can you? Yeah, that's not possible. So it doesn't matter about the third power. If I can't take the square root of a negative number, I'm basically done, aren't I? Do you remember what we wrote in a previous lecture? Yeah, this is not a real number, is it? It's not a real answer. It's not a real solution. This makes us go to a whole nother world to find that answer. This one we can't do. And don't just skip it. I mean, you need to write this or something like it. Because if you don't write this, then I'm assuming you skip the problem, and so does the book, so to speak. So does the homework program you're working with. Cool? Okay, so stay tuned. I got some more problems for us. Okay, back with some more problems. Now, mind you, the directions haven't changed. They still say simplify, if possible, and write with positive exponents. Got it? Okay, so let's look at number 5. In parentheses, I have -64 to the -2/3 power. So what's my base? Good, negative 64. Why? Because it's in parentheses. The entire thing is in parentheses, the negative and the 64. So that's your base. Now, 2/3 I understand, but a negative exponent? We kind of have to remember what that means, don't we? Do you remember what a negative exponent means? Some of you do, some of you don't. Here's the very short version of it. Negative exponents mean that this problem is in the wrong place. It doesn't belong where it is. I'm going to come back to 5. Let me look at 6 for a second, because this one is visually more obvious, right? It's just visually more obvious on number 6. Do you notice I have 1 over a to the negative 2/3? The a is on the bottom, right? The a is my base and it's on the bottom. But do you notice the power is negative? Okay, so here's what that tells me. It tells me that this a is in the wrong spot. Where is it currently located? It's currently located in the denominator. Well, if it's currently located in the denominator and the negative power tells me it's in the wrong spot, then that means it doesn't belong in the denominator. It belongs in the numerator. So, the a is going to move. And the 1, though, stays in place because the 1 doesn't have a negative exponent, so it stays in place. The a is going to pop to the top, so to speak. And when you move it to the top, the power is now going to be positive because it's a happy camper. It's in the right location. Now, this was a division problem, but as soon as you move this a to the top, this division problem becomes a multiplication problem. Division and multiplication are opposites of each other, so it makes total sense. They're opposites of each other, so it makes total sense, okay? Now, when I simplify, 1 times a to the 2/3 is a to the 2/3. And I can't take the 2/3 power of a because I don't know what a is. With me? Okay, so back to number 5. This has a negative exponent, which means this negative 64 doesn't belong here, does it? Technically, this negative 64 is in the numerator. And since it has a negative power, it doesn't belong in the numerator. It actually will belong in the denominator. So this negative 64 is going to drop to the bottom, but the power is still 2/3 on it. And you're like, well, what's left on the top? Isn't there an imaginary 1 sitting here? 1 times that? So the 1 is on the top. Cool? Okay, and now you have to figure out negative 64 to the 2/3 power. So remember what we did in the last 4 examples. This means that we are taking the cubed root of a negative 64, aren't we? And then we end up taking to the power of 2. Agreed? Well, what's the cubed root of negative 64? Good. That is a negative 4. And you're taking a negative 4 to the power of 2. What do you get? 16. Which means this answer is 16. Cool? Again, the negative power meant this base, in this case, should be on the bottom, because technically it was in the numerator, so I needed to move it to the bottom. And then it became a problem I'm used to dealing with. I know how to take negative 64 to the 2/3. That means I'm going to take the cubed root of negative 64 and then take that answer and square it, which in this case will give me a positive solution. Okay? Okay, let's look at number 7. Now, I have another negative exponent. Does it belong there? Nope, where does it belong? On the top. Now, here's my question to you. That negative exponent, what is it sitting on? Is it sitting on the 3y or just the y? Some of you have the answer and some of you aren't certain. So remember, if it's supposed to be on the entire 3y, what should be around this? Yeah, it should be parentheses, just like up here. The negative goes with the 64. Why? Because it's in parentheses, right? Okay. So in this case, take a gander. Does the 2 have a negative exponent? No. So does it move? No. So we leave the 2 alone on the top. Does the 3 have a negative exponent? No. So should it move? No. So it stays on the bottom. Does the y have a negative exponent? Yes. It's currently on the bottom. Should it stay there? No. I pop it to the top. And now its power becomes positive because it's in the correct location now. And I can't take the 7th root of y, let alone raise it to the power of 5, because I have no idea what y is. So that stays as it is. Cool? Okay. Let's look at this one, number 8. Yep, I have a negative exponent again. So does the 8 stay here? Nope. Where does the 8 go? Good. The 8 belongs on the bottom. And the power then becomes a positive 4/3 because it's a happy camper. But what goes on the top? Yeah, just like problem number 5, there's an imaginary 1 hanging out front. Because 1 times anything is just itself, which is why you never really see it, but it's always there. And now you got to figure out 8 to the 4/3, don't you? Which means you're taking which root? Good, you're taking the cubed root of 8, and then eventually you have to take it to the power of 4, don't you? Well, what's the cubed root of 8? Good, 2. And now you got to take 2 to the power of 4, which is 16. Oh, by the way, total coincidence. These two answers are the same, so just saying. Don't always think the answer is 16. Anyway, good? With me? Okay. And by the way, don't always think that the variables are on the bottom with a negative exponent. Sometimes they're on the top, and you got to move them to the bottom. Right? Okay, just making sure you understand that. So, if you need to rewind this, right, look at these last 8 problems, make sure you understand them, because what we're moving into now is actually working with the rules of exponents. But now my exponents are going to be rational, and I need to make certain that I remember those rules so I know what to do when I've got these rational exponents. Do I add these exponents? Do I subtract these exponents? What do I do? Well, depends on the problem, right? Okay, so stay tuned for those